The section formula can be used to derive the midpoint formula for a segment on the coordinate plane. Because the midpoint separates the line segment into a ratio of 1 to 1, substitute 1 for both m and n into the formula. And remember that 1 times any number is simply that number. So the midpoint formula on the coordinate plane is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. If line segment PQ has endpoints at P, x1, y1, and Q has x2, y2 on the coordinate plane, then the midpoint M of line segment PQ has coordinates M, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Find the coordinates of M, the midpoint of line segment AB, for A is -2, 1, and B is 8, 3. So first, let's identify our x1, y1, x2, y2. So x1, comma, y1 is point A, x2, comma, y2 is point B. Now we're going to substitute into the midpoint formula. X1 is -2, x2 is 8, y1 is 1, y2 is 3. So we're going to substitute those in. -2 plus 8 is 6, and 1 plus 3 is 4. 6 divided by 2 is 3, and 4 divided by 2 is 2. So the midpoint, point M, is 3, 2. Talk about it. Would the coordinates of the midpoint be different if you use point A as x2, y2 and point B as x1, y1? Explain. Teachers, pause the video now so students can talk. The midpoint would not change because the location of point A and point B have not changed. We're still talking about the same exact segment, and the midpoint of the same exact segment will always be in the same exact place. Also, addition is commutative, which means you can switch the order and you will still have the same result. Students, please try the check on the screen. Teachers, please pause the video now. So the first thing I'm going to do is I'm going to label my x1, y1, and x2, y2. x1, y1 is for point A, and x2, y2 is for point C. Then I'm going to substitute those values into the midpoint formula to find the coordinates of point B. So I've substituted them in. Now I'm going to perform my addition. -3 plus 5 is 2. -2 plus 10 is 8. 2 divided by 2 is 1. 8 divided by 2 is 4. So the location of point B is 1, 4. Find the coordinates of A if P is 3, 1/2, is the midpoint of line segment AB, and B has coordinates 8, 3. We can use the midpoint formula in order to figure this out. Recall that the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So the first thing we're going to do is substitute the known information into the midpoint formula. Let A be x1, y1, and B be x2, y2. And of course, M in this case is standing for the midpoint. So we substitute our midpoint in for M, and we substitute x2 and y2, the coordinates of point B, into our midpoint formula. Next, write two equations to solve for x1 and y1. First, to write the equation for x1, we're going to take the x-coordinate of our midpoint and set it equal to the expression for the x-coordinate in our midpoint formula after we've substituted in the coordinates for point B. We're going to multiply both sides by 2 and then subtract both sides by 8 to find that our x-coordinate of point A is -2. To write the equation for y1, we're going to take the y-coordinate of our midpoint, which is 1/2, and we're going to take the expression that represents the y-coordinate from our midpoint formula after we've substituted in the values from point B. We're going to multiply both sides by 2, and then we're going to subtract 3 on both sides. So we end up with our y-coordinate being -2. Caution. In this example, the x-coordinate and y-coordinate for point A were the same, but that is not going to be true in every case. So we can plot these points on our coordinate plane to check for the reasonableness. So we can identify the horizontal and vertical from A to point P, and the horizontal and the vertical from point P to point B, and see if they are the same. So to go from -2 to +3, that's a horizontal move to the right, 5. To go from -2 to +0.5, we went up 2.5. To go from 3 to 8, that is a +5 horizontal move. And then to go from 0.5 to 3, that is a vertical move of 2.5. So that actually is the same vertical distance and same horizontal distance between points A and P and points P and B. So we know that our answer for point A is reasonable. Find the coordinates of A if P is 3/1/2, is the midpoint of line segment AB, and B has coordinates 8, 3. So this is an alternative way of finding point A other than using the midpoint formula. So the first thing I'm going to do is I'm going to write A, P, B in a vertical line. A is the endpoint I'm looking for, P is the midpoint that's given to me, and B is the other coordinate that is given to me. Now I'm going to find a pattern. So to go from +3 to 1/2, I'm going to subtract 2.5. I'm going to do that same subtraction to find the coordinate of A. So my y-coordinate for point A is 1/2, +1/2 minus 2.5, so it is at -2. I'm going to do the same thing for my x's. To go from +8 to +3, I'm going to subtract 5. So I'm going to subtract 5 to find the x-coordinate of point P. 3 minus 5 is -2. So the coordinates of point A are -2, -2. And those are the same coordinates that we found by using the other method, the midpoint formula. Which method is the most efficient? Turn and talk. Teachers, please pause the video now. Check. Find the coordinates of Q if R, 6, -1 is the midpoint of QS and S has coordinates 12, 4. Teachers, please pause the video now. Regardless of which method you use to solve the check, you should have gotten the coordinates of point Q to be 0, -6. Students, please complete the exit ticket that is on the screen and turn it in before you leave today. Teachers, please pause the video now.